Yeah. Hi everyone. My name is Balaji. I'm studying in Institute of Aeronautical Engineering, Dundigal, Hyderabad, and Computer Science and Engineering with specialization of AI and ML, that is Artificial Intelligence and Machine Learning in first semester. And today, as per my concept of AAT concept videos, my topic in the subject Engineering Physics is Bragg's Law. We have been seeing this Bragg's Law since our 10th class or intermediate, and here in this video we will know about what is Bragg's law, what does Bragg's law describe, what is the derivation of Bragg's law, what are the formulas we use in it, what are the abbreviations of terms we use in Bragg's law, and also what are the applications of Bragg's law in daily life for a engineering student or a daily life of a common man. Yes, coming to Bragg's law, coming to introduction, as I said, we are going to describe what is Bragg's law. Here you can see Bragg's law describes how X-rays interact with crystal atoms. From the chapter called crystal structures and crystal atoms, we can take that space lattices. We have space lattices and Brevis lattices. These combinations, whenever we are going to complex stages in this problems, then we use this Bragg's law, where we used to find the interaction of X-rays with that with the particular crystal atom, and also when X-rays strike crystal planes, they reflect in specific directions. When an X-ray is coming into an crystal atom, here maybe the crystal atom, it after reflection it may be refracted or reflected. This diffraction, this how much it get diffracted from the angle of incidence, that is called angle of incidence and angle of reflection. What is the diffraction between these two angles, what is the difference between these two angles is called diffraction. And by this Bragg's law, we know we will get the abbreviation for it. And constructive interference occurs only at certain angles, as we know from destructive interference and constructive interference. The whether maybe constructive interference needs much more complex situations and preferred situations to perform constructive interference. And here, this principle helps scientists determine crystal structures. As I said, scientists in our daily life, scientists wherever they do a research or an experiment on some specific crystal structures, then they think about how to do, what to do, and what is the angle of diffraction, what is uh, diffraction angle of X-rays. They have to know about it. And coming to the next slides, we'll be knowing about it. Bragg's law's basic formula: n into lambda is equal to 2d into sine theta. Here you can see the abbreviations, that is n is equal to order of reflection. Order of reflection means in which order. It may be first order, second order, third order, fourth order, and early stages on the orders. Whether the diffraction or a reflection is getting placed in first order or second order, that is the number denoted by n. And lambda is wavelength of X-rays. Every wave particle has an wavelength, so that this X-rays wavelength should be denoted by lambda. And d is equal to distance between crystal planes. We may take two crystal planes, three crystal planes. The distance between first crystal plane and second crystal plane should be denoted by d. And theta is equal to angle of incidence or angle of reflection. As I said, the difference between these theta will be called diffraction. That is called angle of incidence or reflection. That is between these theta 1, the difference between theta 1 and theta 2, delta theta, is called diffraction. This formula gives the exact condition for constructive interference. And coming to the next slide, going to the derivation, before going to the derivation, we will be going to see the diagram of Bragg's law, how the X-rays come into it, how X-rays perform the activities, that we will know. The description of the image will be given here, that is X-ray beam strikes crystals at angle theta. You have to imagine, whenever I am saying, when you imagine, you can know more about it, you can be attracted towards it. So X-ray beam strikes crystal at an angle theta. Whenever the X-ray angle is coming, it will be striking the crystal atom. At what angle, at which angle the X-ray is striking to the crystal atom is called angle of incidence. And reflected beams toward two plane interfere. They will be diffracted or reflected towards two interference. Spacing between these planes, the first plane and second plane, is called d, as we know. How? Now let's go to the diagram. Yes, here is the diagram. Incoming beam. Here you can see incoming wing. 1 minute. I could. Yes. This is incoming beam going to here, and here it is hitting the crystal structure, and from here it is getting diffracted, and here it is happening in the first interface, and here it is happening in the second interface, and this is angle of refraction, this is angle of refraction. Here theta. Okay, let me arrange this. Okay. Yeah, now okay, you can have a look at this clear diagram. Yes, going to the next slide. Derivation for Bragg's law. The main course outline, course outcome of our this video is what is Bragg's law, what are the laws of what are the abbreviations of Bragg's law, how will we use Bragg's law, what is the derivation to deduce Bragg's law. Yes, here. Consider an X-ray incident to two parallel crystal planes separated by distance d with angle of incidence theta. I take a crystal structure or a crystal plane, place it in a medium, and then you pass a beam of X-ray onto it and calculate the angle theta where the X-ray beam meets the crystal structure, and between after refraction of these two they have after reflection calculate the distance d between both the planes, first plane and second plane. And here step 1, going to derivation, identify the extra path. What is this extra path? the second ray travels in the second ray travels an extra distance AB while entering, BC while leaving. Yes, you can see one. Yes, BC value. Total path difference is equal to delta is equal to AB plus BC. Yeah. Next, going to this. From geometry, AB is equal to d sine theta. Wherever you have seen in the diagram, AB, where this distance d into sine theta. Sine theta is angle of incidence. Sine of that angle is equal to sine of that angle into interplanar distance gives the length of the line AB, and BC is equal to d sine theta from the abbreviation. So AB is equal to BC. When we have AB is equal to BC, both are of same length. That is incidence ray and refracted ray. Both are of the same length, so they both are equal. Also, their consecutive terms should be equal. That is AB is equal to BC, d sine theta is equal to d sine theta is equal to, so that we can have that delta is equal to AB plus BC, so that AB is equal to d sine theta, BC is equal to d sine theta. Then we can have delta is equal to d sine theta plus d sine theta. That is delta is equal to 2d sine theta. And here next we go where n is the order of reflection, lambda is wavelength of X-rays. Combined equation is equal to 2d sine theta is equal to n into lambda. And final formula here we get n lambda is equal to, yes, n lambda is equal to 2d sine theta. Yes, concepts of Bragg's law derivation. What is the main theme? What is the main concept of the this Bragg's law? What is the main concept of this Bragg's law equation? How do we use this in our daily life? And that we can know here. X-ray reflect from multiple equally spaced crystal planes. X-ray reflecting from multiple crystal planes. There may be one, it may be two, it may be more than two. How many crystal planes you have to calculate the distance, and this X-ray may be passing through any crystal plane one of them. It is unpredictable. It may be anything, and the second beam travels extra distance that is equal to 2d sine theta. The distance which it traveled from the first refracted ray, the distance of the second refracted ray is more than the first one here. And also for constructive interference, the path difference is equal to n lambda, n into lambda. As we know, n is equal to number of this one what's this n is equal to number of this thing, and lambda is wavelength of X-rays. N is equal to maybe it may be 1 2 3 or 4 number of crystal planes how much you take, and Therefore, 2D sin theta is equal to n lambda. This how we have been derived it just now before in the previous slide. And also, I want to conclude this with calling where do we use this Black's law? Why is this important? Why should we learn this Black's law? Why is it more important for a student to know about Black's law when he is studying about crystal structure? See, whenever you go to your career path next time, whenever you go to reach research side or development side, then you have to make some PhD reports or you have to make some experiments. Then you have to get a basic knowledge about that. What is X-ray? What are the properties of X-ray? How much wavelength can X-ray hold? What is the wavelength denoted by? That is lambda. And how many crystal planes can I take? What is the limit of crystal planes I have to take? And what is the interplanar distance? And what is X-ray diffraction? What is angle of incidence or what of angle of resonance? When you know all these basic concepts, you maybe if you don't know anything, you maybe practice it more and you can be eh, performing it well in your laboratories or anywhere. Yes, in applications of Bragg's law, here we can see crystal structure determination. When determining a crystal structure, it may be space lattices of Breville lattices, it may be made of any lattices. There are many types of crystal structures. Whatever the crystal structure you take, you have to determine it. When determining it, you have to get its diffraction and get its um, angle of diffraction. Then you have to use Bragg's law to get it, obviously. And measurement of interplanar spacing. What is measurement of interplanar section? That is the distance between two crystal planes and used in X-ray diffractions. XRD we call it many ways we see here how much the X-ray get refracted, laser diffractions, X-ray diffractions, moreover anything. And material science and solid state physics, the subject when you have to go to PhD or anything. And identifying unknown substances through diffraction pattern. What is this? Identifying unknown substance through diffraction pattern. See, every crystal structure and every substances in this universe has some shape or has some properties. Whatever. Now, air has the lightweight. That's a property. A laptop have it's a more weight. It's made up of metal. It's a property. Everything has a through these properties we make an X-ray pass through it and we calculate the diffraction of it, and according to that diffraction pattern we can identify what substance that is belong to, what is the substance and what does it perform. And that's it. That's the applications of Bragg's law. I hope everyone understood, and thank you for watching. And also, I always believe in a quote, and always I will be reading some quotes. And as that quote for the day, I remember is science is a way of thinking much more than it is a body of knowledge. Science is not about by hearting from the textbooks or learning from seeing the such like this videos or something. It's about experiencing it. You are living in physics. What is physics? Yeah, man's life is physics. We're born in physics and died with physics. Whatever he does, whatever he does in daily life is comes under physics. So that's why I believe in this. Science is a way of thinking much more than it is a body of knowledge. Thank you, everyone. Thank you very much.